Okay, in example B, we're looking for the limit as x approaches 3 of the function x minus 3, all divided by the square root of the quantity x minus 2 minus 1. So we're going to go ahead and rationalize this denominator by multiplying the top and bottom by the conjugate of our denominator. And that's going to be a square root of the quantity x minus 2 plus, because we want the conjugate, 1. And we're going to multiply that same value in the denominator as well. Square root of the quantity x minus 2 and plus 1. And that's going to form a difference of squares in the denominator. So we'll simplify to get the limit as x approaches 3. And in the numerator, we'll have that factor of x minus 3 and a factor with the square root of the quantity x minus 2 plus 1. In the denominator, we have a difference of squares. So the square root of the quantity x minus 2, that squared is just an x minus 2. And then we'll subtract because it's a difference of perfect squares, and 1 squared is 1. Then a negative 2 minus 1 is a negative 3. So we have a factor of x minus 3 in the numerator and a factor of x minus 3 in the denominator. Those will cancel and leave us with a limit as x approaches 3 of the square root of the quantity x minus 2 plus 1. So if we were going to graph this, we would have a radical function, which would make an arc shape, and it would go 2 units to the right, up 1 unit, and it would have a hole in it as x approaches 3. So we're going to find the y value of that hole by looking at the limit as x approaches 3. And we'll do direct substitution. So under the radical, we'll have 3 minus 2. And then that evaluates to the square root of 1 plus 1. And the square root of 1 is 1. 1 plus 1 is 2.